Okay, na? Start.
Started.
Dear students, good morning. Let us see how to use the design data books for the design of machine members 2. Okay, here we have two different data books. One is PSC data book, another one is Mahadevan data book. Okay, we can use both data books for the exams. Okay, let us see the first one, bearings. Okay, so the bearings from the Mahadevan data book that contains chapter 15 and 16. Chapter 15 is the general bearings. The page number is 349. And for general bearing, chapter 16, page number 371. Similarly, from PSC data book, chapter 4, that is the roller bearings. And for general bearing, that is chapter 7.30 to 7.41. Okay, let us see one by one. First, let us see the PSC data book. This is the PSC data book. We have taken the 7.30, that is general bearings. So here you can see the materials, characteristics, limitations, applications. In the exams for the theory questions, sometimes what are the different materials used for the general bearing. So you can write different materials directly from the data book. Sometimes they may ask applications. So you can write directly the different applications. Sometimes they may ask what are the characteristics of the materials or for general bearing. So here also for different materials you can write the different characteristics. Sometimes they may ask limitations. So based on the question we can use data book. Okay, this is the design practices for the general bearing. So this table will be used to solve the problems. Okay, so in the problems, let us take design a general bearing. Okay, in that bearing they will mention the type of the application like centrifugal pump, reciprocating compressor, and steam engines. So in the problem they will mention the name of the application. Most of the problems they will mention the centrifugal pump. Okay, so for that we need the data like L by D ratio, that is 1 to 2, and bearing pressure 7 to 14, and Z value and Zn by P value. Okay, here Zn by P is the value is 2844.5. Okay, so these values you can refer from the data book. Same values also you can refer from the Mahadevan data book also. Okay, if you take Mahadevan data book, here also we have different notations. Okay, so in that problem sometimes you can find out the bearing pressure. We have a formula, load for 2 into R into L, projected area. This is projected area, so this will be useful. And also sometimes they may ask find out the power loss or heat generated. That is the formula is H is equal to FWV, where F is the coefficient of friction. Okay, the same formula also available in the PSC data book, that is mu WV, Okay, just wait. See, this is the heat generated formula. Heat generated H is equal to mu WV. You can use the same formula directly to find out the heat generated, or you can use this formula from the Mahadevan, that is FWV, power loss or heat generated. Sometimes they may ask to find out the power loss, or sometimes may ask heat generated or power loss due to friction. Okay, with the different names, or heat loss due to friction. So for all the terms the formula is same, that is Hg, formula mu WV, where here mu is the coefficient of friction, here F is the coefficient of friction. Notations are different and remaining are same. And here V is the velocity, that is 5 dN by 60. Here I have a formula 5 dN by 1000. but you have to take 5 by 60, that is the rubbing velocity. Okay, and also they ask to find out the heat dissipation, that is HD. Okay, here we have a formula HD is equal to, here this is not suitable, here you can use the formula. I will show you the formula, that is this is HC, already told you, this is HD, Ka delta T, Ka delta T, this is the temperature difference. Okay, where TB is the varying temperature, Ta is the atmospheric temperature, A is the surface area. Okay, HD is the heat dissipation. Okay, here TB minus TA, you can take it from Databook like 1 by 2 TO minus TA. 1 by TO, O is the operating temperature or oil temperature. Here A is the atmospheric temperature. Okay, sometimes they are not given varying temperature directly, so you have to find out oil temperature. Then you can find out the TB minus TA. Then substitute the same value here. You will get the HD value, that is heat dissipation. This is heat generation and this is heat dissipation. Okay, so like that you can find out the both formulas. But the gap is not false. Then also we have a table, same table. Here different materials, okay, and their properties. Okay, these are the with applications. This will also be used for the theory question. Okay, so same table as mentioned earlier. This is the table from the Mahadevan. Let us take one application, that is centrifugal pumps. Okay, here also you need a pressure, maximum pressure value, that is 0.7 to 1.4 mega Newton per meter square or Newton per mm square, and Z value and Zn by P value you can take 29.01. okay, and C by R value, C by R 0.0013, and L by D ratio 1 to 2. So this data will be used to solve the problems. In the theory questions, they may ask define eccentricity factor, and minimum film volume thickness. So for those you can draw this figure directly. This is the mechanism of the hydrodynamic general bearings. So in theory question you can write this figure directly. These are the different formulas, these are the terminology. This may be useful for the short answers. Sometimes in the problems they may ask find out the coefficient of friction variable, flow variable, flow ratio, pressure ratio, temperature ratio variable. Okay, by using these formulas you can also find out, okay, for example if you take this is the mu, so from this formula you can find out the coefficient of friction. Okay, similarly here Q is the heat flow, so D is the diameter. See here also you can refer, see here where S is the Sonnenfeld number, Q is the oil flow, QS is the axial flow, C is the specific heat, delta T temperature difference. Okay, so by using Sonnenfeld number, here you can find out the coefficient of friction. Sometimes they may ask find out the flow, that is oil flow. So to find out the oil flow you can use this equation. So like that you can use. Sometimes they may ask find out the maximum pressure, they will give the pressure ratio. So from this you can find out. Sometimes may ask find out the change in temperature rise, you can use this formula. So this data is already available in the table, that is this one. So from this table, see here in the question they will give the L and D values, that is the L by D ratio. From L by D ratio you can find out the value. So corresponding L by D ratio, again you have to find out the 2H by C ratio. Okay, they will give you a 0 and C values, then you can find out this value. Sometimes also you can find out the Sonnenfeld number. So for that you have a formula. So once you find out these values corresponding to L by D, you can choose the required values. Okay, like that. Here we have a formula. See, this is a coefficient friction variable. This all the data is available here. Okay, to solve this type of problems, we can use this table and these formulas. These are already directly available here. Okay, you will see one problem later. This table will be used. See, this is the temperature. This is different types of oils. This is the absolute viscosity. Okay, here we have three different parameters. In the question, they may give pause. Okay, direction. Okay. So here we have temperature, viscosity, and type of oil. In the problem, they will give temperature and viscosity. So by using these two parameters, you have to find out the type of oil. Sometimes they can give temperature and the type of oil. From these two, you can find the viscosity. Okay, let us take for example. Suppose if the temperature is, let us take temperature is 70 and the type of oil is SAE, for example SAE 30. Let us take SAE 30. Okay, the oil is SAE 30, this one. Let us take temperature is 70. So here both are meet at this point. This is 70 temperature and this is 30 oil. Okay, SAE 30. So here both are meet here. So you have to find the corresponding viscosity here. That is 20. That is 20 centipoise. Okay, like that you can find out. Sometimes suppose if they are given some 15 centipoise, that is viscosity, and they will give the some, for example, so some temperature here. So here 20 is, let us say 20 is the viscosity, and let us take 70 degrees the temperature. So from 70 and 20 you can find out this line, that is SAE 30. So like that also you can find out the type of oil. Okay, this is very useful table.